All right, welcome back. So example 1, we're going to see how to differentiate this function right here, the function y equal to 2x cubed minus 5x times 3x plus 1. And the first thing we want to do when we're kind of presented with a function like this is to just identify what's the main operation that's going on here. And what we see is that there is, it's not explicitly written, but implied here, right in the middle, we have this first term, the 2x cubed minus 5x. We have a second term, 3x plus 1. And right in the middle there is multiplication. Right in the middle there is some multiplication going on. So we actually need to use the product rule here. We have a product. If we look on either side of this multiplication, there's x terms over here, there's x terms over here. So we have a product of x terms. Variable terms. There's some x terms in this term, in this factor, and there's some x terms over here as well. So whenever we have variables times variables and we want to differentiate, that's where we use the product rule. All right, so how does the product rule actually work? And again, just really emphasize, we have a product of two variable terms here, of two functions. All right, so how do we actually implement the product rule? Well, let's just start by writing down two copies of our function. So, whoops. We'll do a 2x cubed minus 5x. And then we'll do a times 3x plus 1. So there's our first copy. And then just write down a second copy. 2x cubed minus 5x times 3x plus 1. And then in between those two copies, we'll put a plus sign. Now, we're going to be calculating the derivative. So this is going to give us y prime. And we've written down two copies of our function, put a plus sign in the middle. Now let's apply the derivative to, in the first copy, to just the first term. And then in the second copy, we'll apply the derivative to just that second term. All right, so then that's the product rule right there. We've just done the product rule. So it says when you have the product of two functions, you differentiate the first function times the second function plus the first function times the derivative of the second function. You can really think of that, though, as just write down two copies. So one copy of our function plus a second copy of our function. And then in the first copy, apply the derivative to just the first function. And then in the second copy, apply the derivative to just the second copy, or second function. And then from here, you just keep differentiating. So this isn't, we're not done. We still have some derivatives to do. So we keep going until there's no more differentiation. So we have to differentiate the terms inside these brackets. And this is something we can just do. These are polynomials. We can just use regular power rule and sum rule and all of that. So we've seen how to differentiate the terms just inside here. So what is the derivative of 2x cubed minus 5x? Well, for that first term, it would be 6x squared. And then we go and differentiate the minus 5x. That's minus 5. So derivative of this first piece then is 6x squared minus 5. The 3x plus 1 here is outside the brackets, so we don't do anything. And then the 2x cubed minus 5x here is also outside the brackets, so we don't do anything there. And then we need to finish differentiating this piece over here. We need to differentiate the 3x plus 1. And that's something we can do. So derivative of 3x is 3. And then the derivative of that 1 by itself is just 0. So we end up with a 3 there. And perfectly good. There's our derivative. So we could simplify this if needed. As you're just starting out on these, just worry about getting the derivative. But, there's things we could do here to simplify this down, multiply everything out and go on. And as we'll see in the next example, and it also is true for this one, technically we didn't actually have to do product rule. We could actually just multiply our function out first, get it as a polynomial, and then just differentiate from there. So this one's just to kind of get things going, just to get us started with some product rule here. So you can check it out for yourself, though. Try multiplying this out, and you wouldn't have to necessarily use product rule. All right, let's try another example. Let's differentiate the function h of t equal to the square root of t times 5t plus 2. So when we look at this thing, first of all, it's not explicitly written, but it's implied that there is multiplication going on right in here. So I want to identify kind of the main operation. And for this case, it's multiplication. So if we look on the left side here, there's a variable term. We look on the other side of the multiplication, and there's a variable term over there. So what we have here is a function on this side, a function on this side, and then we're multiplying them together. So we have the product of two functions. So again, we need to potentially use product rule. So let's try it out. Option 1 here. We're going to actually do this one kind of two ways. So first way, product rule. And before we start getting into this, we're going to rewrite that root function. So we know when we differentiate root functions, it's usually helpful to rewrite them with an exponent as a power function. So just keep this in mind. We're going to change that square root t to a t raised to the 1/2 power. It's kind of a standard thing we do. All right, so we're going to calculate h prime of t using the product rule. So what does the product rule say? Let's implement the product rule. So we'll start by writing two copies of our product. So square root t times 5t plus 2. Then we write a second copy, t to the 1/2, or square root t, times 5t plus 2. So just two copies of our function. We put a plus sign in the middle. And then in the first copy, we apply the derivative to just the first function. And then in the second copy, we apply the derivative to just that second function. So that's product rule. And then we just have to finish differentiating those terms that are inside the brackets. So over here, we need to differentiate this t raised to the 1/2. So this is just power rule. Bring the 1/2 down, keep our variable the same, and then subtract 1 from the exponent. So we go from 1/2 down to negative 1/2 when we subtract 1. So that takes care of the first term there. We differentiated that. This 5t plus 2 is outside the brackets, so it just stays the same. And I know I'm guilty of this. My t's and pluses start looking very similar. So just to be careful for yourself, this is what's going on here. That's a t, that's a plus. So just be careful. And then we have a plus t to the 1/2. That's outside the brackets, so we don't do anything to it. And then we have this 5t plus 2 over here inside the brackets, so we need to finish differentiating that. And the derivative of 5t is 5, and derivative of 2 is 0. And there we go. We have our derivative. And if we needed to, we could simplify this further. All right, so that is one option. Do the product rule. Sometimes it's a little bit easier, or just another way to do it is to actually do the multiplication first. So sometimes we can do this. Actually do the multiplication. So when we look at this, we have a power function times a polynomial. So when we do the multiplication, we're going to be able to simplify the result down a bit. So in this case, maybe doing the multiplication first makes a little more sense. But either way is going to be perfectly fine. All right, so let's actually start with our function, h of t, and let's actually go through the multiplication here. So we're going to take this t to the 1/2, and we're just going to distribute it. So it's going to go to the 5t, and then it'll also go to that 2. So when we do that, we get 5t, and when we multiply powers of t together, we add the exponents. So we have a 1/2 here, and then there's kind of a hidden exponent of 1 here. So we'll end up with 3/2 when we multiply the 5t with the t to the 1/2. And then when we multiply this 2, we just get a 2 times t to the 1/2. And now we've rewritten our function. We've actually done the multiplication. And so now these are just power functions that we're going to be differentiating. So no product rule necessary here. This is just a power function. This is just a power function, and we have a plus sign in between. So how the derivative works is for a sum, we can just, let's really emphasize our derivative rules here. When we have a constant multiple times a power function, we can just apply the derivative to just the power function. So that's constant multiple rule. And then when we apply the derivative here, the 2 is just a constant multiple, so we can really just apply the derivative to that variable term. And we can split them up like this because of the sum rule, because we have addition in between. So just calculate the derivative now. So we have t to the 3/2, do power rule. So take the exponent 3/2, bring it down, multiply it with the 5 that's already there. So 15 over 2. Keep our variable the same, so t. Subtract 1 from the exponent, so we go from 3/2 down to 1/2. And that takes care of that whole first piece. Then we go to our second piece. We have a plus sign, so the plus sign is going to stay in our derivative. Then we're going to differentiate this power function. So take the 1/2, bring it down, multiply it with the 2 that's already there. So the 2 and the 1/2 just kind of cancel. We're left with 1. Our variable is t, so that stays the same. And then if we subtract 1 from the exponent, we get down to -1/2. And so here is another kind of version of our derivative. So you might be thinking, all right, we have this one version right here, and we have this other version right here. And it might be good practice to go through and just convince yourself, go through the multiply all these things out and try to combine like terms, and convince yourself that these actually do end up being the same. So even though they don't look like it, at least right now, these are equal. All right. So sometimes product rule is necessary. Sometimes we can get away with just doing the multiplication and kind of avoid the product rule. All right, so in the next video, we're just going to try a few more examples of doing product rule, just to kind of build up our practice here, just to keep practicing these things. So we'll see you there.